Good morning. Today's topic is wein bridge oscillator. RC oscillators. These oscillators employs resistors and capacitance. Thus the name RC oscillators. These are most suitable for generating low frequency signals, also known as AF oscillators, that is audio frequency oscillators. These oscillators have very good frequency stability. Types of RC oscillators: wein bridge oscillators and R-shift phase shift oscillator. In this session we are going to see about wein bridge oscillator. Basic principles of wein bridge oscillator. It employs two stages of amplifiers. Each stage gives phase shift of 180 degree. Combination of two amplifiers gives 360 degree phase shift, which is equal to 0 degree. A fraction of the output from the second stage is fed back to the input of the first stage without producing any further phase shift. This oscillation can be used from 10 Hz to 10 MHz. This is extensively used as audio oscillator since its output is free from circuit fluctuations and ambient temperature, whose circuit is given here. This is a circuit of wein bridge oscillator. This wein bridge oscillator is a type of the phase shift oscillator which is based on the wein bridge network. Here in this block diagram, a wein bridge network is highlighted where there are two arms, or in that the two arms are purely resistive while the other two arms are a combination of resistors and capacitors. One arm has resistors and capacitors connected in series, that is R1 and C1, and the other arm has a combination of parallel, that is R2 and C2 are in parallel. This indicates that these two arms of the network behave identical to that of the high pass filters or low pass filters. At high frequencies, the reactance of the capacitors C1 and C2 will be much less, due to which the voltage V0 will become 0 as R2 will be shorted. Same time, at the low frequencies, the reactance of the capacitors C1 and C2 will become very high. At that case, output voltage V0 will remain at 0 only, as the capacitor C1 acting as an open circuit. This kind of behavior is exhibited by the wein bridge network, which makes it a lead lag circuit in case of low and high frequencies respectively. Circuit analysis. The circuit arrangements were given in the previous slide. It has two amplifier stages with RC bridge circuits. The bridge circuit has four arms. This is already explained, that is one series combination and one parallel combination and two resistive arms. R3 and R4 are the pure resistive arms, and another arm consists of R1 and C1, both are in series, and R2 and C2 are in parallel connections. The transistor T1 or Q1 with its biasing network serves as an oscillator and the oscillator and amplifier, while the transistor T2 or Q2 with its biasing network serves as an inverter. The frequency of oscillation is provided by the series elements R1 C1 and the parallel elements R2 C2 of the bridge network. Operation of oscillation. Here the two high and low frequencies, there exists a particular frequency at which the values of the resistance and capacitive reactance will become equal to each other, producing the maximum output voltage. This frequency is referred to as the resonant frequency. The resonant frequency for the Wein bridge oscillator is given by Fr is equal to 1 by 2 pi root of R1 C1 into R2 C2. If R1 is equal to R2 is equal to R and C1 is equal to C2 equal to C, then Fr is equal to 1 by 2 pi Rc. This is the condition for frequency of oscillation. At this frequency, the phase shift between the input and the output will be 0 and the magnitude of the output voltage will become equal to 1/3 of the input value. This Wein bridge oscillator will be balanced only at this particular frequency. Working of Wein bridge oscillator. The frequency of oscillation can be produced by varying the two capacitors C1 and C2 simultaneously. These oscillations are fed to the first transistor T1. These are for the first transistors Q1, C1 and C2 are fed to the first transistor Q1. After amplification, these oscillations are fed to the second transistor. First transistor acts as an amplifier and the second transistor acts as an inverter. A total phase shift of 360 degree is obtained at the output of the second transistor. A fraction of this output energy is fed back to the oscillatory circuit, that is bridge circuit, at the upper terminal. This positive feedback is to met with the losses in the oscillator and hence undamped oscillations are produced. A negative feedback ensures the stability and the constant output. This negative feedback is provided through the voltage divider R3 and R4 to the input of the transistor T2. So, this R1 and R3 is connected to the second transistor through voltage divider rule. Usually, the temperature sensitive tungsten lamp is used in the place of R4. Its resistance increases with current. As soon as the amplitude of the output tends to increase, more current could provide negative feedback. This brings back the output to its original value. A reverse action could take place if the output tends to decrease. Condition for sustained oscillation. There are two conditions. First condition is R1 by R2 is equal to 2 and second condition is that 0 phase shift is obtained by both the transistor and the tank circuit in the feedback. Advantages and disadvantages. Few advantages are: here the output is always constant, its working is simple and easy, and the overall gain is very high, and it has better stability, and frequency of oscillation can be easily adjusted. The major disadvantages are cannot be used to generate very high frequencies and it is costlier. Thank you.